All right, welcome to our podcast today. And today's episode is really all about 3D printing. We've gotten some feedback from people that we've talked to that they like the 3D printing episodes. And today we have a great one for you because it's all about things that we've learned, tips and tricks on how to use our printer, but also 3D printing in general. We're going to start out with embedding 3D printers or embedding magnets in 3D printed items. We used to just print a cavity and glue it in after the fact, but if you've ever used a magnet, you know that those are easy to pop out. So we're going to talk about some of the tips and tricks we've used to embed magnets. We're also going to talk about 3D printer spools. Most 3D printer filament comes on spools, but we often get samples or different smaller sizes that don't. So we're going to talk about some of the options we have there. And then this little box here is a surprise for Evan at the end of our episode today. You ready?
Yeah, I'm ready to go.
So I'm going to go ahead and pass Evan over some of our items here. He does a lot of the work. I do a lot of the design work. In fact, I think I designed all of these items, but he did a lot of the work that was involved to make the magnets embed. So we're going to go ahead and let him talk about that component. Actually, let me start. So as far as when we're designing the 3D items, all of these we did with Tinkercad. And you just have to make sure you know the size of the item that's the magnet that's going inside, and then build a cavity inside within Tinkercad. So one of those, I think you can see the circle. If he holds it up, it's that one. If you turn it over, you can see that there's two magnets inside of there. So basically what we're doing when we're in Tinkercad is we're going in and we're saying, hey, we want these magnets, we want this many of them, we want this size, and I position those cavities within the 3D model. And so when it comes to then being able to put those into the software, we can put pauses into the G code so that we can know we need to go over and put those magnets in at that point in time. And you can tell, a lot of times you can't even tell there's a magnet inside that element until you go put it up on something that's that'll stick to.
Yeah, and so what we're doing, there's actually some, we're using Prusa Mark III printers and Prusa slicer. And so there's a really cool bit of G code that'll make it spit the bed out in the front and then raise up and then allow you to put your magnet in and then click the button to keep printing. Recently, I've actually switched to using the color change option. So it's built in. It's so easy. You just click the little plus button next to the layer you want to change. So you slice it, then move the slider up and down to see your different layers. And then on the layer that you want to be after your magnet swap operation, you click the little plus button, and it's technically for color change, but it works great. It pauses the print. It lets you put the magnet in, and you can keep going. So these are a couple of examples. These are actually some N52 really powerful neodymium magnets that are like almost a quarter of an inch thick, and they're quite strong. We were going to use these to hang something in a room. And so this is printed with ABS in an attempt to make it strong. You can see that it needs some cleanup, but that's okay. We just simply haven't done that yet. And then these are just some cheap ceramic magnets that you could get from, a hobby store.
We bought 50 of them for like $5.
Yeah. And then we embedded them in these. This is a clear PETG. And of course, 3D prints are never really clear, but this one is pretty translucent. I think it came out pretty neat. We've also used this technique for RFIDs. And so we have some round RFIDs that are roughly the same size, this round circle. And for example, our Ouija board prop, the most recent one we've done, there's an RFID embedded in the planchette, which triggers the sequence to start. And so we were using a magnet originally, but wanted to avoid the potential for anybody to accidentally trigger it when it wasn't in place.
But the magnet props are really fun for us to work with because it's really simple to detect if a magnet's there or not. That's a pretty easy thing. Some different magnet sensors use polarity, so that does matter. So if the magnet does pop out and then you put it back in the wrong direction, the prop will no longer register that. So that's why we've really taken to embedding them within the 3D printed elements, because it's just easier to guarantee that it's not going to be messed up in that way.
Yeah, and we're typically using Hall effect sensors to detect magnetism, and we have 12 volt and 5-volt and 3-volt versions, and some that are polar and some that aren't. And so you got to make sure you get the right sensor. And the polar ones are nice because they'll only activate in a certain direction, and that way you can kind of use that as a, well, they can put this prop on this thing, this prop on that thing.
That way you can have two magnet props in the same room, but you're not going to accidentally trigger one with the other piece.
Yeah,
which is a common mistake when you have too many things using magnets in a room.
Yeah, and we've also found that the Hall effect sensors are very reliable. I don't think we've ever had a Hall effect sensor fail because they don't have any moving parts in them. Right. We also use read sensors from time to time. They usually have a longer read distance, so a read sensor could be
a little bit more sensitive.
Yeah, up to like 1.5 inches, and but they can eventually fail because they're a tiny little piece of metal in there moving around. So
yep. All right. So let's go ahead and move on to our next item here. So I'll take those back from Evan and pass over our next topic. Most of the 3D printer filament that we get comes on a spool like this. This one's empty, but they would come on a spool like this where it has just a place. I mean, these are pretty similar things that you see for like thread or other pieces. But we often run into situations where what we're using did not come with a spool. So I have a little piece of it here, but it's very common for us to get here pieces that are just free and they don't have a spool with them. And when it comes to 3D printing that, we often have problems with it tangling or just having to put it on the floor and collect whatever dust is on a part of our floor at that point in time. So we sometimes have problems with that. So Evan's come up with a couple of different solutions there. I just wanted to give him a minute about that.
Yeah, absolutely. And if you have any good uses for 3D printer filament spools, let any 3D printer that you know about it, because they usually
we have a stack of 10 empty spools right behind me right now.
Yeah, they are recyclable, but they're all made of different plastics, so you have to be kind of careful about it. And it is difficult to take one of these spools. This is like a 50-gram spool. To put in perspective, a full spool is usually a full kilogram. It's difficult to take these and wind them around there. It takes, it would take a good hour to get everything rewound. So that's where these spool holders come into place. And this is my current favorite. If you used to listen to records, I think you'd have the little adapter this reminds me of a 45 to 33 adapter. But anyway, so this is a print in place 3D print object, which is amazing. So it actually prints exactly like this on the bed. You pick it up and then you snap it, and it breaks free. And then as you can kind of duck your spool in around these forks and then just spin it out, and then voila, you have this one. So this is that small spool that I was talking about. And this is really neat because you can kind of fit whatever the sizes of the spool that you have and kind of click these in place and pop this up on the printer, and it will slowly unreel. I will say that printing these little half spools or partial spools is a pain in the butt. What we found is that they sometimes will get tangled, even using one of these holders. So it is a good idea to kind of hang around and make sure that it's not getting stuck. We haven't found a good solution that's 100% reliable. Here was an older version of the spool holder. And this one is a lot more rigid, but the challenge with it is, in order to use it, you have to spin these out of the way, and then your spool has to be exactly the right size.
So like if Evan tries to put that black one on there, it's just too small. It doesn't fit. And we don't actually have any sample sizes that fit that spool holder. So we like the idea of that spool holder.
Yeah.
We've never used it.
We may make a smaller version because we did subscribe to MakerBox, which gives us 6 samples of filament every month. And they're always something interesting, but it's a pain to print sometimes, just trying to deal with those little partial spools.
So we like this new piece that we found there for us.
Yep.
All right, so we are going to now kind of swap away from that into our surprise element for Evan today. So Evan, if I could have those back, I'll get those out of the way because I've got a lot of different little things, and we might make a little noise when I hand this over to him, which I apologize for all that racket that's about to happen. But today's surprise also has to do with 3D printing. and not necessarily in the most happy way for us sometimes. But I'm going to let him open that and let him tell you what these are.
Okay.
And some of these actually are related to some of the things we've already talked about today, so that's pretty convenient.
I see. So it looks like we're looking at 3D printer fails.
That is correct. We have had a lot of prints over time, and these are just a small sample that I can't even say these are all of them. And what's weird about these is some of these things were things that were great initially and then just failed over time. And I actually have one more example of something that we had a problem with early on that I just don't have any of them left anymore. So I'll let Evan talk about these and specifically why they failed, and then we'll transition to that last item.
Sure. So this was fun. This is polyalchemy elixir, and it's on top of some silver. I think it's just a silk silver from Micro Center. But just FYI, you can do this. Just sort of change your filament in the middle, and then you can get 2-color prints.
Which we love to do. You could tell it with the magnets earlier too. We did a lot of the color changes in the middle of the prints.
Yeah, and so I believe the failure mode of this one was a tangle. Is that right?
Exactly. So as Evan said, if you put one of these, and in fact, I think it was the silver one that he showed us.
Yeah.
Is that one there? It just stopped in the middle. There was a crash detected because it could no longer pull filament through because the filament had tangled over on itself.
Yep. So this print was beautiful and working great, but we left it alone in the room for a little bit too long. Came back and noticed a crash, which in this case wasn't a crash into anything, but a crash in that it was pulling the filament and it was stuck. So, but it's a neat little print.
Yeah. And that actually, we did reprint it. We printed it with some PLA marble, and it worked fine the second time around. Just we didn't get the pretty color swap in the middle of it.
Yeah. So these are kind of fun. We've been printing these little tokens. These are for an escape room box. And here's an example of one that's actually completed. And so they look kind of like that. And here's a couple examples of fails. And so this one on the my right, your left, is an example of a dirty bed. So the PEI bed on the Mark III printer will pick up the oils from your hands and the sugars in the plastic, because this is PLA plastic, which has sugar in it. And it will slowly get less sticky over time. And then this is kind of what it looks like when it starts to lay down the plastic. And so even though the bed is the right distance away from the nozzle, which that's always a challenge, it still wasn't sticking. And so it kind of looks like that. And then this is another one where the exact same thing happened. Just started to get, this one's just not as bad. So this was just part of that failure. So perhaps this was attached to a different one that failed worse. But sometimes it's easiest just to cancel the whole print on the first layer and start over.
Because if it fails later, you're going to be having to do exclusions, and it takes the same amount of time and you get less stuff out of it. It's not good.
Yeah, we do have a plugin for Octoprint, which if you're using Octoprint to print, is wonderful, called Exclude Region, which allows you to draw a box. So if you have a single one of these tiles failing, you just draw a little box around it on the G-code viewer, and it'll stop printing there. And that's really great.
But one of the weird things about that is it pauses there, and it takes the same amount of time during that pause as it would take to print that piece before it moves on to the next piece. So if it's one or two, it's not that big a deal. But if it's half of your pieces, like we said, if you find it on the first layer, it's better to just stop and start over, because you're going to wait the same amount of time to get half the amount of good usable pieces off of it. For both of those, the red and the yellow, if you check out our time lapses that we uploaded last week, and then a more that will be coming up, we'll have a lot of these in ongoing right now. Then we will have on Half-Blood prints is going to be the red ones, and on Printer of Azkaban's the yellow, and you can kind of see what those looks like. And also on Half-Blood prints, I think the blue ones that are turning out well. We haven't had any failures, but we still have several of those to go. So fingers crossed those continue to go well. But we haven't had any failures on the blue, but the red and the yellow, both we had a few.
Mm-hmm. Yeah, and I think that's also just the nature that the top Printer of Azkaban, which is printed this yellow one, is much older. And so the PEI surface is a lot older, and they do wear out over time. So definitely the bottom printer can go longer between getting a good old soap and water bath than the top one does. I have to do the top one maybe every 10 prints or so.
And we're hesitating to replace that surface. It's just time consuming, a little bit painful.
Yeah. Well, you can buy a fully made spring steel sheet from the Czech Republic for $50, or I have the stickers. And so you're supposed to tear them off and replace them and cut them down and all of that. And I'm putting it off because I don't want to do it.
Why don't you do that Ferris wheel next?
Sure. So these Ferris wheels, this is printed in a silver, a PLA silver from G-Tech on Amazon, which is an okay filament. So this one we were printing using Octolapse, which is a tool that allows you to take time-lapse photos of your prints, which is how we do our time-lapse photos on YouTube. And the problem with that plugin, or with any plugin that moves the print head off of the print surface temporarily, is that it usually leaves a little bit of an artifact as that happens. And so in this case, the artifact was on this pen right here, because as it comes through, it prints by layers. We're building up the layers, and then so as the last 10% of the print is actually just printing these pegs, these little pegs.
Yep.
And so all of the artifacting for whenever it moved off, it would leave a little bit of plastic every time it did that, was on this peg. And as I was cleaning it up, the peg broke off. And so the pegs do have a tendency sometimes to be a little bit fragile in this design, just simply because they are, the layer lines are horizontal, and that's usually the weakest direction. So the print is actually quite strong in this direction. But if I were to try to break off one of these pins, I could do it with relative ease.
Yep. And we've actually have other problems with that too. We previously printed those with some silver from Micro Center, and that filament is not as strong as the G-Tech. And so even under the bare minimum of pressure, those pegs would pop off because they just were not as strong. That filament's not as strong as this one is. It's very pretty. In fact, if you look at some of the elixir in that's really what the silk looks like. And so it would be a very pretty and very useful, nice looking thing, but it's also just not as structurally strong as the G-Tech that we ended up using here. The other piece on that wheel, and you can see it on this one, not as much as you could see it on some previous prints, is there's a lot of stringing. I don't know how obvious that is, but what that is anytime the print head is moving, like stops printing, moves to another location, starts printing again, there might be a little bit of stringing, which is just thin layers. Think about it like hot glue. You hot glue something and you move the hot glue gun to another place. There's that string of hot glue that's going between. The same thing can happen with the 3D printer, and it's really annoying. It doesn't really affect the overall outcome in our experience. You can typically pull it off, but it's a lot of cleanup. And the way we adjusted this one, in fact, several prints later, is we've raised the temperature when printing that particular item on the printer head, and then it is reduced the stringing. In fact, the run that we ran last didn't have any at all.
Yeah, and so you can look up something called a temperature tower, which allows you to test each filament. So every filament is a little bit different, and Prusa Slicer has this temperature tower built in that you can print, and it will show you at what point your printer stops stringing very much, if stringing is an issue for you. You can also hit this with a torch or a heat gun, and it'll actually kind of melt the strings. But we usually just...
But we're printing 400 of these 5 at a time. So
yeah, it's a long process.
It takes about, I think, 4 hours to print 5, just because of the level of detail in the model. And we're printing 400 of them. And this is our second run. The first run we printed 650. So this is the second time we're doing this. So at least this time we're a little bit more prepared. We're just using a slightly different filament just because of what's in stock locally for us.
Yeah, filament's definitely been difficult to get. It's finally coming back into stock, although prices haven't come down. So we're still paying pandemic prices for filament. But it's all in stock now. Yep. So this is a filament clip. So we were talking about the spool there, and as you pull filament off of it, you don't want it to unravel, because then you're going to end up potentially with having crossover issues where your filament will get tangled. So what you do is you take the end of your filament and you just clip it to your spool. And these are printed in glow-in-the-dark PLA from Inland, from Micro Center.
ABS.
And these are ABS? Okay. Well,
Same problem either way.
Yeah, the challenge ABS is actually quite a bit stronger over time, but PLA has a known issue, and that is under stress, it has a tendency to bend and permanently bend. And so if you print stuff from PLA like a clip like this, it's generally a bad use of PLA because this little area of plastic right here is the only thing bending. And as it sits here on the spool, it will slowly relax over time because it's being bent, and that will just become its normal shape, and then it will be useless after that. So,
And we've had that problem with these too, even though they are ABS. And a lot of that just has to do with, we've changed it a little bit. Where we were storing them was just a little bit too warm. So now we keep this room cooler. We have 2 3D printers running in it and a computer pretty much 24/7. So we've had to adjust how we're cooling this particular room.
yeah. So definitely avoid PLA for any sort of structure where you think that it's going to be under load for a long period of time and you don't want it to sort of deform.
And I happen to love that clip out of all the 3D printer like spool clips that we used. When it was functional, was the easiest to use and the least likely to pop off. I gave him another one too. It's a small black one. He can talk to you about why that one didn't exactly work either.
Yeah, so Inland changed their spool design, I think about a year ago. I think it's because they switched who actually makes their filament because they don't actually make anything themselves. But you can see there's a little hole where the filament goes through and then a clip that goes around the filament. So the idea is you capture the filament in that little groove and then you snap this in place. And then that's exactly what happens with this. It's very thick. And it's very difficult to put on. And then
It's almost impossible to get off.
Once you get it on, you can't really get it off. So there's 100 versions of this on Thingiverse. You could definitely go find one that will work well for you and your.
But this one was rated high, and then we were like, "Oh my gosh, new clips!" And we printed like 10 of them, and it's like he's going to struggle to get that off right now.
I think that it's possible that this would be a use case where having PLA would be good because PLA is so much weaker. These were printed in ABS, and so it could be that they're just so strong. But I think that this kind of clip it works well. But these are great, and honestly, on a lot of our rolls,
we just use tape.
We just use some Scotch tape.
All the rolls that are behind me right now, where I have taped them off, there are a couple that I didn't, which is bad. They are used Scotch tape. That's it. We just cut that end off and then continue to use.
Yeah. And so this was fun. This was a model that we found on Thingiverse, which is actually made in Tinkercad, which is not perfectly cleaned up yet, but it's a little planter actually. And then we found a lid. I talked to the designer of the lid, and he gave me a version that didn't have anything on it. So we kind of printed that. So we'll make a little box out of it, which is neat, little book box. This was printed in ABS primarily because we want to do post-processing, and post-processing ABS is way easier than other filaments. So you can do things like sanding, painting,
gluing, smoothing, sanding.
ABS has this wonderful reaction to acetone. So you can do what's called a vapor bath, where you just put it in a plastic bin with some acetone vapor. So you're basically putting it on top of a sheet of foil and then
put a bowl of acetone in there. And as it heats up, it'll form a vapor that fills the box. Yep. Smells terrible, by the way, but works really well. And on prints where the quality of the print matters, we will go through and make sure first to print it with ABS, but then also afterwards to go in and do that acetone bath because it'll smooth it and make it look very glossy. Yeah.
And so this print in particular had a ton of structure on it. Support around the entire outside.
And if you've, sorry to jump in, but if you watch there, again, this is in the time lapse from a few weeks ago. If you watch on that, you won't even actually be able to read the books because there's so much structure around the letters in the books themselves that you can't read it while it's printing. It's after we do the cleanup that becomes available.
Yeah, and I just knew that it was going to be kind of ugly after it was all cleaned up. So printing it in ABS allows us to go back in afterwards and either brush on a little bit of acetone to smooth things out or potentially, like I said, vapor bath it. This particular model had a couple of problems. There's actually 2 spots in the model where there were either empty lines or surfaces that were right on top of each other that weren't exactly touching. And so this is an example right here. This top piece was actually printed in such a way that it wasn't firm, positively affixed to the layers below it. So actually it had a layer of empty plastic, empty air in between. And so since we were printing with support, it put a little tiny layer of support in there. And so as I was cleaning it up, it just came right off. And so we're just going to glue it back in place. And so there's an issue with the model, but additionally, the wonderful thing about that acetone feature for ABS is
if you put acetone on both sides and stick them together, they will stick together.
Yep. And then that'll just become a permanent glue. And so acetone will actually melt ABS. And it's cool because as the acetone evaporates, it comes out of solution, and then it goes from a liquid into a solid. And so you can use acetone to do all kinds of cool stuff with ABS.
Yep.
And so we're going to keep cleaning this up and turn it into a Harry Potter little book box.
Yep. And that's for our hidden closet under the stairs. Just gives the kids a place to hide one more thing that they can put there. And that's actually, of all the 3D prints that we've shown you today, the only one that we can fix. The rest of them, once the crash happened and we were unable to, first off, we didn't notice right away, which is on us. But once we were able to get to it, it was so far cooled and we just couldn't get to the point where we could restart the blue and silver one. That peg that broke off is so tiny that if we were to glue it back on, which we could, it would probably pop off again in the future. The carts, again, they're not redeemable in the stretch plastic. There's no way to really get that back to original. But this one, you can just use that acetone, glue it back together, and we're going to be able to use this one once we get it cleaned up.
Yep. I'm really excited to paint it and make it look neat. And so a lot of cosplayers use ABS as well. So if you're printing like a gun or something like that, they'll use ABS because they can paint it a lot easier. And it also
sand it.
It sands
a lot of people will print it, clean it up a little bit. They might use something like Bondo or something to fill cracks if that's necessary, or even wood putty, some people, and then sand it and then just paint it. And it looks really nice.
Yeah. Although the challenge with ABS, of course, is printing ABS because it has a tendency to curl. So printing it in a nice hot little box helps quite a lot.
All right. Well, I hope you enjoyed that. I know this one's a little longer than we normally do, but I really wanted to give Evan an opportunity to talk about some of the things we've learned, especially around the failures. I know that was a lot of things all at once for his surprise. And I know it's not necessarily, as usual, not the most pleasant surprise. I don't tend to give him nice things when it comes to surprises, but I really hope that you learned something from our experience there, especially on how to fix or circumvent some of those issues.
Yeah. Thank you, everybody.
Bye.